Okay. All right, guys. Now, what you have over here is a sample question for velocity versus time. Now, before I teach you on the most important type of question, because if you can answer these questions, you can answer any type of velocity versus time questions now, such as what is the total distance, what is the total displacement, what is the average velocity, what is the average speed. Now, first, let me explain to you the motion of this graph. Okay, because that's the most important thing that you need to understand. Now, let's just say you have a question like this. How do you need to understand this question? Now, from 0 to 2 seconds, you can clearly see that the velocity is increasing. Am I right, guys? The velocity is increasing all the way until 5 meters per second. Now, if I ask you, what is the acceleration? Because from 0 to 2 seconds, your vehicle over here is accelerating. Now, you take 5 and you divide 2. The value over here will be 2.5 meters per second square. That means it's accelerating for 2 seconds over here. And at 2 to 6 seconds, you can see that the velocity over here is the same. That means the velocity here is 5. That means from 2 to 6 seconds, if I ask you, what is the acceleration? You tell me the acceleration is 0. Okay. And this one over here, if I ask you to calculate for me, you will tell me 5 divide 2 and I'll get 2.5 ms negative 2. You can write negative 2, you can write /2 over here. Okay. And at this time, 6 seconds, this is where over here the brake is applied. And from here, 6 to 8 seconds over here, the car decelerates. Okay. Now, the car decelerates all the way until time over here, 8 seconds. And from 8 to 12 seconds over here, the car or the vehicle moves in the opposite direction. That means all the way until 8 seconds, it was moving in the same direction. Let me just put it for you like this. Now, that means A, B, let's put it as A, B, C, D. Okay. All the way until D, it was moving over here in, let's just say, the positive direction. And then over here, from point time 8 seconds over here, all the way until over here, time 12 seconds, it was moving over here in the opposite direction. So this one is the positive direction. And then from D all the way until, so this is D, E, F. So until F over here, it was moving in the negative direction. Okay. Now, first, how do you calculate distance? How do you calculate displacement? Okay, guys. Distance and displacement. Okay, please listen. Distance and displacement is the area under the graph. Okay. Now, very important. Area under the graph. Okay. So area under the graph over here gives you distance or displacement. Now, let us calculate over here for distance first. Okay. Now, for distance, let's see here. So you have over here this particular graph. Okay. Now this one, let's just take 1 over 2 times 2 times 5. All right. Now, keep this as a nice bracket over here. Plus over here. Now, this part over here, 6 minus 2 over here, you have 4. So 4 times 5. So this one is 4 times 5. Okay. And this particular triangle, because you see, you have one triangle here, which is this. Okay. And then you have one rectangle over here, which is this. And then you have another triangle over here. This one will be 1 over 2 over here times 2, 8 minus 6, 2 times 5 over here. All right. Now, over here, plus, let me just put a bracket for this. Okay. Plus over here, the last triangle that we have down here, which is 1 over 2 times over here. So 12 minus 8 over here, 4 seconds times over here with 5. Okay. Now, I know that there's a negative, but we'll ignore the negative for the time being because distance, no direction. Okay. So over here, let's calculate. So this one will give you 5 meters. Plus over here 4 times 5, 20 meters, plus over here another 5 meters, plus with over here 10 meters. So in total over here, 20, 30, 40 meters. Now, your distance is 40 meters. Okay. Now, what happens over here is, your distance, as I said guys, it is a scalar quantity. It does not have over here a direction. Your distance is just simply over here, area under the graph. So whatever area that you have over here under the graph, that is your distance. Now, how do you calculate over here your displacement? Now, your displacement over here, I'm just going to write here. Your displacement over here, remember, now you have this, okay, as 5 meters, plus you have this as your 20 meters. You have this triangle over here, which is your 5 meters. And yes, you remember this triangle. Now this triangle is moving over here in the negative direction. So when it's moving over here in the negative direction, this is where you will plus over here negative 10 meters. So technically over here, your displacement will be 20 plus with over here 5, 25, 30, 30 minus 10, 20 meters. Okay, this is the value of your displacement. Okay, now to calculate average velocity and average speed, I'm just going to discuss very fast over here on this. Average velocity, basically you will take over here displacement divide over here with your time. For average speed over here, basically you will take over here your distance and you will divide it over here with time. Okay, now displacement over here divide time, I don't think so there's any problem. Your displacement over here is 20 meters and your time over here, you have to take the total time, which is 12 seconds. Even for your distance over here versus time, it's the same thing. Okay, your distance over here, which is your 40 meters over here. So you just need to take your 40 meters, divide over here with your time. Okay, so over here, remember, displacement divide time, you get your 20 over here, dividing your 12. Distance divide time over here, you just need to make sure that you take your distance, which is 40, and divide over here your time over here, which is 12. All right. Okay, done over here for velocity versus time.